Welcome for physics lesson. We're going to study floating and sinking. Part 1, we are taught to state the law of flotation. And the law of flotation states that for a floating object, it displaces its own weight of the fluid on which it floats. Therefore, if an object is floating, it will displace its own weight of the fluid on which it will be floating. Part 2, explain why a hollow metal sphere floats on water while a solid metal sphere of the same material sinks in water. So if we have a material sphere, which is a hollow, then we have another one, which is a solid. The solid one will have a bigger weight than the hollow one. When you dip them or you place them on a water surface, they are going to displace equal volumes of water, which means they are going to experience equal upthrusts. And if they are experiencing equal upthrusts, then the one with a bigger weight is more likely to overcome the upthrust as opposed to the hollow one, which is not having a bigger mass. Therefore, the solid one is more likely to overcome upthrust as compared to the hollow one, because this one will have a bigger mass, resulting to a bigger weight. Part B, we are told that the figure 7 below shows a uniform block of uniform cross-section area 6 square centimeters floating on two liquids A and B. The lengths of the block in each liquid are as shown. Given that the density of liquid A 800 kilograms per meter cubed and that of liquid B 1000 kilograms per meter cubed, determine part 1, weight of liquid A displaced. So now we can see the solid. The solid is having a total height of 6 centimeters because we have 2 centimeters in liquid B, 2 centimeters in liquid A, and we have 2 centimeters which is not submerged, rather which is floating. Therefore, weight of liquid A displaced, we're going to get first of all the volume of liquid A displaced. Volume of A displaced. And the volume of A which is displaced, because cross-section area is 6 and the height in A is going to be 2, then we use cross-section area times height, which is 12 cubic centimeters. Now we have the volume already. We can have the density converted, because the density of A is 800, so we use 0.8 grams per cubic centimeter, which means now the mass is going to be density times volume. 12 times 0.8, 12 times 0.8, 12 times 0.8, 9.6 grams. So 9.6 grams can be rewritten as 9.6. We divide with 1,000. We want to get the weight. So we have to get the mass in SI unit and we multiply it with G, which is 10. So we multiply by 10 and we divide by 1,000, and this will give us 0.096. This one will be newtons because we have made them weight now. So 0.09 newtons. Part 2 of the question tells us to determine the weight of liquid B. The same solid is submerged. The same solid is submerged 2 centimeters in liquid B, which means the volume of B will be cross-section area 6 times 2, which is going to be 12 cubic centimeters. Remember, the density of B is 1,000, which is 1 gram per cubic centimeter. So the mass, which is given by density times volume, is going to be 12 times 1. This is 12 grams. We can make it weight by saying that weight is mg, whereby we'll have the mass converted to SI units times g. So when we get 120 divided by 1,000, this is going to give us 0.12. 0.12 newtons. So we have the weight of liquid B displaced, the weight of liquid A displaced, and now we want to calculate the density of the block. We should know that according to the law of flotation, any floating solid displaces its own weight of the liquid on which it floats. So this means weight of the block is going to be the weight of A plus the weight of B, the two weights added. It is displacing 0.096 of liquid A and 0.12 of liquid B. So when we add the two 0.096 plus 0.12, I'm getting 0.216 newtons. So this is the weight of this solid because it displaces liquids which are adding up to such a weight according to the law of flotation. So this means now we can get the volume of such a solid. Volume of the block, we said its total height is 6 and it had a cross section of 6. It is having a total height of 6 because we have 2 centimeters submerged in the first liquid, 2 centimeters in the second liquid, and a portion of 2 centimeters which is hanging in here. So which means its total volume will be 36 cubic centimeters. So we can convert the weight into mass because density is given by mass out of volume. Mass itself will be given by weight out of g. So the weight, the mass is going to be 0.1 or 216 divided by 10, which is 0.0216 kilograms. And we can change these kilograms into grams. We can change the kilograms into grams by multiplying them with 1,000. So this is going to be 21.6 grams. So we have the volume in cubic centimeters and the mass in grams. So density can be given by mass divided by volume. So when we divide by 12, not 12, 36, sorry. When we divide by 36, we're going to get 0.6. These are grams per cubic centimeter. The density can also be converted into 600 kilograms per meter cubed. Thank you for following. Subscribe and share.